So we're going to go ahead and get started. Today's webinar is on critical capabilities to shifting left the right way. So when we look back over the last 70 years, testing has changed quite a bit, especially for the tools that have hit the market. But testing actually occurred by the same people who wrote the code 70 years ago in the 1950s. And in those scenarios where, with regards to software development, it actually happened throughout the project. There was no dedicated testers at the time. So this idea of shifting left, this idea of testing earlier isn't exactly new, but the term shift left itself has really reignited its importance. And that's why we wanted to focus on this topic today, because we know that there is a lot of people who are interested in learning how to shift left, learning why it's important, the key skills and features required to shifting left in those tools, and how to overcome top challenges to adopting that. So we have a couple people here to walk us through all of these aspects and give us a live demonstration of a shift left use case within a SmartBear tool, TestLeft. And before I go ahead and start this webinar, I want to go ahead and do a quick introduction. So my name is Akshita Diorapuram. I am a product marketing manager here for the test portfolio at SmartBear.
Hey everybody, my name is Prashant Mohan, and I'm the product manager for Test Complete and TestLeft here at SmartBear. Thank you everyone for joining.
And good morning or good afternoon, good evening from wherever you're from. My name is Param Chopra. I'm one of the sales engineers here at the US office at SmartBear.
All right, so let's go ahead and get started with what shifting left means today, what it is, why bother doing it, some case studies for people who have actually in companies that have started shifting left and the benefits that they've seen from it, and then how to really get started. So I think the first and foremost thing we want to do is kind of cover some misconceptions about shifting left. So let's take a look at the first question. On a software project, it's often the things we didn't know at the beginning that end up making the biggest impact on a project's success or failure. Prashant, what do you think about this? Is this true or false?
Yeah, I mean, this is something that we come across every time. I think the answer is very, very obvious here, and in our projects here in SmartBear itself, we've seen that collaboration right up front is critical to success of a product. And the more we combine and the more we collaborate different stakeholders at the beginning, that's when a project is actually determined if it's successful or not. Param, did you want to add anything to it?
I think that, I think like any project, right? A lot of building applications, testing applications is certainly iterative processes. And so you certainly want to try and obviously plan to cover all your bases in the beginning, but more often than not, it is very difficult to do that, right? To really capture perhaps the entire scope the first go around. So I certainly think that is true.
So what about the next one? Is it easy to estimate how long it will take to fix a defect?
No, I don't have an official answer, but when I was in school, I was told, coding's going to take 90% of the time you're going to take to write your code, and you spend another 90% of the time testing it. So it could certainly take anywhere from, a couple hours to days, right? It really depends on defect, whether maybe it's a small UI bug, something, some script was miswritten, or perhaps, it's entire logical error, right? That determines how your pieces function.
Mm-hmm. And the third one, good developers don't need to test their code. Is this true or false?
I always ask my developers this, the same question, and their assumption is always that they don't need to test code, but this is absolutely not true. One thing that this webinar is trying to focus on is that how developers are instrumental in the shift left process, and that means that testing is imperative when they write their code. So we'll deep dive into how developers can actually help in this process, and then we'll take it from there.
Well, Prashant, we're going to have to send this webinar to your developers. Hopefully it helps them shift left as well. Okay, let's talk about what shift left is. It's So shift left is an approach to software development where quality is considered and testing is performed earlier in the life cycle. So often the question that we get is like, who is actually shifting left? Who is a part of shifting left, and what it actually means? And there's a couple of things that it could actually boil down to. One is that testers are involved earlier on. Second is that business analysts, product owners, product managers are writing requirements in the form of tests, which is really cool concept because that allows these requirements to be test ready, which then inherently allows the code that developers are working on to also be test ready. And then the third one is developers write tests. And then this could come in any form. And we're going to talk about what this actually means throughout the presentation. But overarching, it's also important to understand the benefits of shifting left and why it's important. And that really boils down to kind of 3 customer values that you are always kind of probably concerned about within your organization. One is speed, quality, and cost. With speed, you get shorter cycles, so you can achieve faster time to market. With quality, you may get fewer defects. And with cost, you realize that it is actually cheaper to fix a defect if you find it earlier in the development cycle. So let's look at a traditional software development life cycle and what that means to actually shift left and the impact on the cost to fix a defect earlier on.
Right. So, IBM conducted a study where they tried to see, just as Akshita discussed, right, at what point in the development phase, let's say from design, development to test or operations, what's the average cost of fixing a defect? I think, I think everyone's guess, right, it seems that the curve certainly rises exponentially, right, as time passes. And we can, at least surmise this where it's going to be more expensive to find a bug during test or perhaps even in production, right? A bug in production could lose you a renewal, could lose you a customer if you're on the sales side, things like that. And production bugs and tests as well usually will be lengthier to fix, right? Just given that just the process of sending the bug back to development, getting that fixed, retesting it, et cetera, et cetera.
Yeah, and I think this is a really cool study. And this goes back to kind of the true and false we did earlier with regards to, is it hard to judge how the cost of fixing a defect? And I think this study that IBM ran a few years ago is super powerful because it does show that the cost significantly increases as you move along the software development cycle. So this idea of finding bugs earlier on makes it easier to troubleshoot and actually helps you with that bottom line within your organization too. And now in this webinar, we're talking about shifting left or shifting test activities left. But shifting left is actually a concept that can happen for all phases of the life cycle. So develop can shift left, test can shift left, and the monitor side of it can also shift left. And as you can see from the second graph, as you continue to shift left, the number of defects will also decrease by that blue bar, but also the cost will too, which is super powerful.
Right. And I think, the reason why we can shift not only let's say bug discovery left, so to speak, but also the rest of the steps as well is because this is implemented in a very agile type of format, right? You can see that there's some overlap between the 2 discovery boxes, right? Between develop and test. Now, the idea to implement this shift left concept is that you have small teams or agile teams where have some developers, testers, business analysts, DevOps guy working together, right? In a more iterative development cycles. So that's the idea. You kind of reduce your time, kind of remaking your project or improving upon it in a shorter cycle so that you can get more feedback quicker and improve your product and application or test quicker as well.
All right, so let's go back and let's talk about shift left. Oftentimes there is an idea that, is shift left really happening? And there's a couple things that gives us a sense that shift left is actually happening in the market. And I'm going to have Prashant talk about this.
Yeah, absolutely. Thank you. Through the past 3 months or so, I've been doing several experiments, talking with product managers, business analysts, architects, developers, testers, different people, and just to figure out if this is actually something that's happening in software teams. And the answer is absolutely yes. And there's several reasons for it, right? So so talking to developers, the one thing that's important is that they don't think about creating code that is testable, and now that mindset is changing a little bit. So they are writing code that is testable, so automation engineers on the other side, or developers themselves, are able to test that code easily. So it just helps us create less flaky tests. Another important thing that came out of the experiment was that the bridge between dev, QA, and the product teams is significantly declining, and it's another thing that's important to notice as the shift left DevOps movement is happening. Another great feedback is that, with the whole agile methodology, coding is done in sprints. I think that's something that we are now religiously sort of following in different teams, but testing is still a little bit behind. So with tools that empower developers to test, empower more technical folk to test within development environments, they can also test in the same sprint. So that's truly agile now. Maintaining a single code base is also essential. So you want to be able to test at the application level, at the UI level, and at the API level in the same code base. You don't want separate tools. You don't want the typical constraints of automation software or of other tools that don't fit into your environment. So you want to maintain a single code base that you can run as part of your continuous integration pipeline. And yeah, so one of the key takeaways from developers testing in IDEs is that it enables true continuous integration and continuous delivery. You are not going out of your environments, and that just significantly improves the whole delivery process. And finally, the most important thing is we are now thinking about quality in every step. It's not just QA's job, it's not just a tester's job, but it's everyone's job to maintain a high quality of the product.
Mm-hmm. So now let's take a look at real life companies that have transitioned to shifting left. When we look at a very traditional software delivery company, this is something that we're all very familiar with, but it's really, when you look at how those release cycles and how their testing is conducted, you notice that there's long application and innovation cycles, right? You're delivering at once or twice a year. You are saving your end-to-end testing, your acceptance and performance testing for that very last step right before deployment. And you're finding a lot of bugs in the QA phase. The discovery is not occurring outside of the QA phase. Teams are running in silos. So really there's this handoff that occurs between the different departments that are involved, a handoff especially between dev working on their code and not throwing it necessarily, but handing it off to the QA team. And then their API, if we're looking at end-to-end testing, many of those features of the core product and developers find it hard to work with. But now let's take a look at companies who have changed their model, like Blackcomb Airlines, who have actually received the benefits of shifting left. And it goes back to those three qualities that we talked about earlier, those customer values: speed, quality, and cost. But in addition to those three, there's this aspect of collaboration, which is so essential to the shifting left concept. With speed, we talked about how it's like shorter cycles. You get to market faster with the shorter development and testing cycles because you are really cutting down that discovery that's occurring only in the QA phase in a traditional software development lifecycle. By cutting down the discovery or pushing that discovery to be earlier, the going back and forth of fixing those defects or prioritizing which defects to fix doesn't necessarily have to occur in the QA phase. You can make that troubleshooting and that fix faster, allowing you to get to market faster too. This allows more predictability needed to kind of hit that deadlines and those budgets. There's not the scramble at the end that many of us are familiar with. For quality, you can test continuously over the SDLC. So this really harnesses the essence of continuous testing. You can find more bugs in at all layers of the application. You can increase test coverage with baseline regressions and unit testing. With cost, we talked about how it's really cheaper to fix a defect earlier on. And that's something that Blackcomb Airlines also kind of benefited from when they started kind of moving towards this concept. And this collaboration piece shouldn't be underestimated, because this is very powerful. But shifting left really requires developers to take part in testing and then collaborate with their QA counterparts and vice versa, strengthening the overall product. So this is, sometimes to many people who we talk to about shifting left, and companies and customers we talk to, it's not always easy. And I do want to kind of highlight the challenges of shifting left and then kind of talk about how we can overcome those challenges. But when we take a look at shifting left today, it seems kind of a daunting experience to kind of go through this. But it is something that even if you are able to kind of overcome in not necessarily a greenfield way, but the more you put into it, the more you'll get out of it. But that doesn't mean that even when you start a mindset of collaboration, you can start benefiting already from the idea of shifting left. But some of the challenges that often people talk about are the increasing complexity of systems. So it may be hard to shift left if you have a complex product suite, or technical skills are needed to shift left, right? Because you want someone who is familiar with maybe testing in an IDE. Team collaboration is something we talked about earlier. Cost of tooling is sometimes depending on the tool that you use. And then corporate buy-in. It's important that the leadership is on board with shifting left and promoting and advocating for a mindset of shifting left on this collaboration aspect. Without that top-led leadership, it can be very difficult to kind of get everyone on board to adopt this concept. So how do companies who have gone through shifting left really be successful? And that boils down to a couple things. And I like to call this mnemonic Empower. So M stands for the changes that need to occur in a mindset. P stands for processes, W for workforce, and then R for resources. And we'll talk about each of those elements and what actually requires a change for you to successfully shift left. All right, so let's do mindset first. We want to shift towards a collaborative mindset. Mindset. Shifting left requires an update in how you think about an organizational structure. So some characteristics of this is like starting your SDLC with the end in mind. So making requirements to development test ready. So we talked about this earlier and how, if you start with, testing in mind from the beginning with regards to your requirements, that allows a lot of things to be test ready. And then that way your code can be test ready and it's easy to kind of have that discovery occur earlier. There's this shared understanding of objectives and goals for all stakeholders in each phase. So, we talked about who's involved in shifting left. So the PO, the business analyst, all of these people are really going to be critical people to empower and have a shared understanding. This is usually the hardest part of shifting left. So one of the things that can help people get started is aligning incentives and metrics for quality at every phase of the development cycle. And as Prashant was saying earlier, this is already occurring.
Yeah, and I have an example. I was just reading this book yesterday. It was really interesting. Starting with the why, that's what it's called. And one of the examples that they gave is a group of American executives, car executives, went to Japan and to check out their automobile assembly line. And towards the end of the line, there was a specific last part where the door fits into the hinges, and then as soon as that happened, it automatically went into the next step. And so the car executives were like, "What? You don't have anyone at the end using a rubber mallet and checking if the door actually fit in the hinges correctly?" And the Japanese then said that, no, we did that during the design phase. We made sure that the outcome was to fit exactly in the design phase, and we don't need someone at the end physically or manually checking it out. So that was a really interesting example, and that comes with collaboration right at the beginning. So you design your outcomes when you are writing your requirements. So it's a key thing that not very intuitive. So I thought I'll just speak about that.
And the next one is a change to your process. So you want to create one process, one language for all of those stakeholders involved. And this usually is really accelerated when there's by certain processes like agile development, like continuous testing, like end-to-end test automation, because all of those aspects, all of those processes and those words and those trends that are occurring are really demanding the collaboration of product, of development, of QA, of operations to be successful. So when it comes to agile development, I believe one of you guys were talking about this earlier, but agile development really is this short iterative development cycles, and you kind of end with the feature being shipped in the end. But the reason why agile development is successful is because it evolves through a collaborative effort from the different stakeholders, and that's going to be really key. Kind of like speaking back to that collaboration aspect of shifting left in general.
Right. And, I'm just looking at the title of the slide, right? One process, one language. And we understand that teams might have certain unique requirements when it comes to that, right? Maybe you're testing, a legacy app versus an app that's doing production. Maybe they have different code bases, right? So, then you ask, well, how do I, simulate my workflow in that sense? Well, that's something we'll be actually talking about a little bit later in this presentation, but it got me thinking about, let's say using behavior-driven development as that one process and language, right? So we can certainly abstract all of our business logic, all of the, actual low-level actions that our applications need to do in these more common to understand statements that, let's say, can be written in Gherkin, but just something I thought I'd share.
Yeah, great.
Given the slide.
And then continuous testing. You are able to automate the execution of automated tests even during deployment, which is also automated for CI, for continuous integration and continuous delivery to occur. So that is another aspect that accelerates shifting left. By allowing for continuous testing, for allowing for that test automation testing to occur throughout the SDLC, that it will also require collaboration with your development counterparts. And then end-to-end test automation. You're creating automated scripts to replace manual UI and API testing across the SDLC. So this is not just the unit testing and functional testing that may occur in development and test and QA, but also performance testing. So you're creating automated scripts throughout this process, which allows you to also enable a one process, one language for the entire, all the stakeholders involved. So next is workforce, breaking down workforce boundaries. And this is really kind of an understanding that, hey, we need to also collaborate with these other counterparts, and that will require us to work with other areas regardless of departmental boundaries. And that's going to be really important. We keep honing in on collaboration because that really is the essence of shifting left, and that really key additional customer value that brings to the table. And because it drastically shifts the way we deliver software, this is why we are also seeing new jobs and skills hit the market. So you see roles like software development engineer and test, DevOps engineers, QA engineers, and that's because of this also idea that maybe there more is a demand for technical skills to allow for shifting left in general. And so we're not saying that you want to hire testers, but you want to hire curious developers and devs that aren't afraid to write unit tests, that aren't afraid of the shifting left concepts, that aren't afraid of getting involved, and they have that curious and that aptitude and that appetite for it. So I think that's really what breaking the workforce boundaries is all about. And the last portion is the tools. So the resources that are involved in shifting left. And this is really optimized with those new technologies that are allowing you to do more with left. So we talked about test automation, BDD is this other aspect that we're going to touch on in this presentation, in this webinar, that really accelerates shifting left. And this is about creating feature stories based off of those user requirements that can be automated and then turning simple requirements into test cases to verify functionality. In addition to automation and BDD functionality that these new technologies have, it's also test management. You want a good test management tool that allows you to achieve efficiencies, because this other aspect of shifting left is this test reusability that gets really enabled, and that can only be optimized with a good test management tool. So there's a couple things that, shifting left is accelerated by. We talked about Agile, we talked about CI/CD earlier, and now BDD. There may be some people that are familiar with BDD, some people that are new to BDD. So I want to lay out the foundation here, because this is a really key important that is also gaining a lot of traction in the market. And that's because BDD enables you to start your SDLC cycle with the end in mind. You can start a software development process where teams create simple steps on how an application should behave from a user's perspective. So when we look at the kind of the old way TDD, test-driven development, you see that it's coming from a functionality perspective, that it's focused on a developer's view on how the software should work. But we're really talking about BDD being a focus on the user's view on how the application should behave, by allowing us to start building out requirements right from the beginning based off of this user perspective. I don't know if any of you are familiar with this this graphic or this picture, but this really, I feel, encompasses the value of BDD and what it's all about, and taking and understanding the user perspective all the way from the beginning. So if you look at this, you can see the first image is about how a customer explained it, of building a swing that he or she wanted, and how the project leader understood it. And maybe how the sales, all the way at the end, top row, how the sales executives described it to the person. And then all the way at the bottom, at the end, you'll see that what the customer actually really wanted or needed. And this is really why it's important to kind of prioritize the user perspective. And this is what BDD accomplishes. So there's 3 important practices with BDD. One is discovery, formulation, and then automation. Discovery is that shared understanding of that user requirement through collaboration. Formulation is the examples of system behavior. So you're taking those user requirements that people are building that they want, or the features that they want, and you're turning that into feature stories based off of simple language that anyone can understand. So a business analyst at the beginning can understand, that a developer can understand, and then a tester can understand. And then automation is really taking those feature stories that you've created in formulation and creating them into test cases. And so we're going to show a live TestLeft demo, how you can do that, how you can turn those feature stories into automation. So I'm going to go ahead and we're going to just switch off to Karam, who's going to actually show you TestLeft, which is a SmartBear tool that allows you to start testing earlier, allows you to start shifting left, and a live use case of BDD within the tool itself.
All right, so very quickly, what we're looking at here are some open source behavior-driven development tools that are popular in the market now. Cucumber for Java, Specful for C#.net, and JBehavior for Java as well. And I know we spoke about BDD briefly earlier, and now, of course, leading up to this demo, but that's a big, I think, use case for this tool specifically. TestLeft itself is more about front-end UI testing and giving developers necessary pieces to help them build test frameworks and their cases faster, more modular fashion. But we're talking about this tool in terms of BDD workflow because we are saying it's a useful tool to use and process to use in shifting left, right? You can use these Gherkin statements, as you can see, perhaps on the next slide. I think we have an example on the next slide. Sure, actually, I might as well just go to my demo. All right, so for example, I have a sample Gherkin feature file right here on the screen. I want to make sure we can see it. And so the idea is that even if you are working across perhaps more disparate frameworks, right, we can combine our workflow and have a more abstracted view of what we need to do from this feature file here. So for example, we're working with a very simple orders application, which I can bring up in a second. It's got a UI, you just add an order, you could delete order, it's just rows of data. But the idea is that, you know, even if my testers are of different skill level or working in different languages or environments, we can combine all our workflow and together write a file like this, right? At either a low level, as we can see here, right? Given I've launched orders application and I've logged in, I'm going to add a new order, then I should see the new order upon returning to the list. But we can also make Gherkin statements at a higher level, a more business logic level, right? So that, as Akshita and Prashant were hinting at earlier, the user experience is more thought about earlier in the cycle, right? So that you're covering more bases earlier in the cycle as well. So not only is BDD useful just as a way to kind of allow non-technical and technical people to work together in their workflow, but it also allows you to, I think, more comprehensively scope out exactly what you need your application to do for your customers and clients, with, let's say, using less words, less work overall. So take a look at this BDD file here. What I can do, and what users generally do with a Gherkin file like this, is they will go ahead and generate step definitions. And I can do this in, again, with SpecFlow in Visual Studios, or right now I'm using IntelliJ and I'm using Cucumber as well. And all a step definition, for those of you who don't know, is simply a method or function that is then annotated or tagged by one of these BDD statements above. So for example, I have this given I've launched the orders application, right? That is annotated and implemented over here, right? And so what happens is when I generate a step definition, I'm given the entire structure of this method, right? The annotation, the method signature. And then from there, I would use, you know, open source, or in this case, TestLeft tooling, right, to fill out the code that will go in said method. So that's essentially how we can build our test cases. And this certainly supersedes TestLeft in general, right? I'll go into what our tool can do in a second. But this is definitely a largely growing, it's a growing technology, and I think very important in an agile development lifecycle, because again, you know, I can go very easily from something high level like this, right, and then go directly and implement it in a lower level. So not only does it allow, again, my testers and developers, business analysts to work together, but then, you know, it even allows my business analysts to read this test case, look at the BDD statements, and know exactly what is happening, right? You have more sharing, more reuse, as Akshita said, more collaboration across your team as well. So let's dive into TestLeft specifically now, which is certainly a tool we believe is different from one of our other tools we have, Test Complete. It's aimed more at a developer crowd, and the idea is that it fits, I think, certainly nicer in this shift left ideology, being a little more free form. So, for example, have this BDD statement here, right? Given I've logged in using username and password. You'll notice I have some nice weird symbols here. What's cool about this feature file is that I can data drive from the feature file, by either throwing the data directly in the statement or by using a Gherkin data table. And so again, just another quick example, right? My business analyst can easily data drive a test case that could be very functionally complex, all from this more simple to read Gherkin statement. But let's take a look at that second statement, right? I have logged in using username tester and password test. And so you see some steps here, right? We are setting some text in the username, password, we're clicking on a login button, and we're asserting that the, let's say, next page is visible. So, you know, even if this is code, this is still relatively readable, right? If you just maybe took a couple seconds, looked at each step. And this is definitely, I think, what, you know, at least when we talk to, in terms of our clients and other developers out there, they would love to achieve code like this, right? Albeit this is a small example, the idea is, you know, using object-oriented practices, being modular in your test design, so that not only is your code a little more readable and just less code to deal with, but then it's more reusable and modular as well. So how do we get to these statements here, right? If I'm using an open source tool, I may have to, you know, script out my entire page object model from scratch. That will certainly be too time consuming. So then, you know, my code might not be very clean. I'm using a lot of local drivers, object identifications, things like that. But how did I get this clean, readable code? That brings us to using TestLeft UI Spy, which for those of you who use Test Complete, it's basically the same exact thing, but it's going to have a couple of different functionalities that'll be useful for a developer right in their IDE. So I'm just going to quickly launch my application here. And I'm just going to launch all parts of it just so we can kind of see exactly what we're dealing with here. All right. So all I'm doing is I'm just opening up all the relevant parts of my app. So in my app, it's 3 pages, right? A login page right here, viewing all the orders page, and then adding a new order, right? So I want to test the entirety of this application. So for example, I want to log in to start my test. I need to go ahead and set some text in my username box. Let's say once I'm at the URL. So how do I go about doing that? If I'm using an open source tool, I might have to inspect the element here, right? Or maybe it's a desktop application. I have to go ahead and know exactly where the control is located in an object hierarchy, what it's called, what the path is to get to it, right? So I have to spend just as much time identifying the object to use as I am testing it. And again, that's certainly going to add a lot of time. It's not a very, agile friendly process right here, right? So how can TestLeft aid in this? Well, we can save you all that time in not only identifying your object, but actually scripting against it in that sense as well. So, okay, I want to go ahead and identify this username control and go back to my IDE, and directly I can launch the TestLeft UI Spy. At first glance, this UI Spy is simply just an object repository showing me every single control and application running in Windows memory. So this is certainly nice because I can use this tool for both my web and desktop applications, right? Same code base for both. And unlike, let's say, a Selenium, we're not relying on an API, right, to identify let's say, controls in your web page. We're looking at the controls as they exist in the DOM layer. And so as we keep this repository live and running, right, if your source code updates, if your objects update, we'll track those changes real time. Now, what I can do is I can certainly search this list for my control, but I don't want to go ahead and do that. Let me take my object spy and simply manually select the object I want to work with. So again, this is certainly very nice because my developer or tester who know how to write code can still easily grab the information they want, right? We certainly know they don't need that much hand-holding, being developers or coders in nature. But, we decided what's a tool that can kind of, aid in saving them times and the things that they don't want to do, right? They want to write cool test code. They want to really, try and make sure applications hitting all of its corner cases. They don't want to spend time in actually identifying the objects themselves, right? That's not the interesting part of this. So in this example, if I have my username here, I can right-click it in my hierarchy. And I can simply copy the identification of it. I can also maybe directly script against it with all this other data we have here. But this is the nice part about TestLeft. I get that identification, and wherever I'm, implementing my code, my method or test code, I can do a little Control V and generate that object for us right here. And so what's happening, to quickly describe those who might not be too familiar, we're instantiating a local driver, and all a driver does is it allows us to then access any control running in Windows memory, right? That's what it's allowing our code to do. We can have TestLeft not generate this entire phrase. For those of you who are asking, hey, will you generate a local driver every time you get an object? The answer is no. It can totally attach to an existing process, but this is more for the sake of example. But then from there, right, we're using a series of pattern matches to go from the web page object to the URL to the panel, and then, of course, to the text box itself, right? And so all this code generated for us, the only work I may have to do now is what? I would just say, text box. Right? I could just easily set text on this. I could click on it, right? My test actions now come in line pretty easily because all the work to get that object's been done for me, right? Imagine writing that out from scratch, which you most certainly have to do in Selenium. And if you didn't want to rely on this giant, 15, 14 lines of code, you could, script your own page object model, a series of classes and methods to describe your application. That's even more time consuming. So we definitely don't see a lot of users doing that consistently, right? But with this tool, I can get these code instances, these code pieces right away, allowing me to test even faster. This is certainly a nice benefit of TestLeft, especially when you think, hey, name of the game of Agile is speed, right? Now, while this is certainly useful, to my earlier point, I may not want to have this block of code every time I'm referencing my text box, right, in my test case. It's certainly not going to make my code readable. It's not easy to reuse in a modular sense, right? And it's going to make my tests very brittle. And again, this is a thing we see with users using open source tooling in their attempts, especially to shift left, right? They're not building test cases that are truly reusable, slowing that agile process down. So how can I do this? How can I accomplish this with TestLeft? Well, I can generate an entire page object model for my application in 2 clicks. So, for example, I say, okay, let me go to my application here, right? I don't want to just create instances of the objects here. I want to copy a whole object model. So let me get my object spy. Select some panel on the page, and let me go to the parent process here. And you'll notice that I have all of my tabs open for my different web pages right here. That's important. So you want to have that open in your browser. So when I go in my browser layer that's running my application, right, I can right click this and copy the entire model. And then with a copy paste or a control V, go back to my IDE, go into a class I'm trying to implement. And I just generated 500 lines of code, just like that. And so if you take a look at what's happening here, let me go to the top actually. We created an entire model of my application as it existed in this instance, right? You can see the parent of the model. It's simply called browser. But I could rename this, of course, maybe web orders app model. You can see that the model takes in through its constructor an argument of type browser. So the cool thing about this model is that it's browser agnostic. I could record it on Firefox like I did and then totally launch it on an instance of Chrome or IE or Edge, right?
That's pretty amazing. Like, I just want to highlight that piece just to make sure that I understood that correctly. So you generated all that code automatically, and if we were using any other tool, like an open source tool, we would have to manually program that?
Yes, this would all be manually
cool.
scripted with Selenium. Yeah, maybe I should have stayed on that point a little bit longer because it is, I'm used to demoing this, so maybe it's not interesting to me anymore, but I'm glad that everyone else is.
That's pretty awesome. Like that automatic generation, It seemed like you just did that in a few clicks too.
Yeah, two clicks to be exact, right? I went to my UI spy, click the parent process, copied the model, and then maybe, maybe to save myself some clicks, I did Control V. But what I think is very impressive is not only that the code is generated, but everything is neatly commented and indented as well, right? You're getting an easy to reuse and readable structure. I think a big thing developers strive for is building readable code. And so one of our other aims with TestLeft is to help developers do just that. And when you build code that's readable and reusable, that's something you can maintain over a longer time period as well, allowing you to be more agile in your processes, right? So everything is commented for us. And the other beauty of this is that we're giving this to you in your IDE. You want to restructure this, you want to recomment it, change the control names around, you're more than welcome to do so, right? Kind of like what TestLeft does with record and replay, this is very much a means to a start for your testing. As you can see, it's a huge jump start versus having to build out this kind of model yourself.
And what IDEs does it work with?
So technically, you can put this in any source code editor you'd like, right? I can generate code in either Java, VB, or C#, right? I can change what the code looks like if I want to attach to a current process, or let's say something from the main function, and then of course change the language of the output as well. And technically, TestLeft integrates in terms of being launched from IntelliJ, Eclipse, and Visual Studio. But again, I can run this as a standalone tool and put code in any source code editor that I'd like.
So if I was using something like Sublime, it would be
totally as long as you have the necessary, Java binaries to compile your code. Yeah. Totally.
Okay. Very cool.
And can you test desktop applications as well with this?
In fact, that's another big benefit of TestLeft, right? You don't have to rely on 2 different code bases to test your, let's say, legacy desktop apps and your web apps. You can use the same tool for both. As I can tell, I could totally launch my desktop applications and run a US spy on that. For the sake of time, I won't. But that's really nice, right? And you can really save yourselves a lot of time and energy by not having to have, multiple tools or multiple language sets to test your web and desktop applications. Kind of finish off here, my main point is this readable code aspect, right? Building something that, because it's not about, oh, great, I saved time in generating my code references, but it's really what the references are themselves, right? Not only do we give this to you in a couple seconds, but this structure, right, allows you to say, if I want to log into my application, it's not going to take, like, let's say, this is obviously a sample a sample one. I'm just going to delete it because I don't want it to, let's see, I don't want it to have to ruin my code right now when I run this test for you guys. But let's say let me cut that. If I go to my actual web orders model I generated for my application, right? Instead of having, 15, 16 lines of code to get my username box and then, set text on it separately, I can just call this method do the same thing, right? That's nicely nestled under a login page class, which is under my web orders application class, right? All nice modular pieces, like boxes of Tupperware fitting in one another. Then, right, I can take that, when I implement it, I'm using one line of code to do an action that was earlier taking 15, right? I instantiate my orders model right here. Again, I can feed it whatever type of browser I want. And then from there, I'm just using object-oriented programming practices to get my objects, right? In this second method here, orders, I have an orders object. I use a dot operator to call the get login page, returns that login page class. And then I use another dot operator to get the username edit method from that class. And then I get a set text method I use there to set text on the argument that is returned again, right? So I can be way more implicit in my object references, saving me a lot of code space, right? And these one-line statements read really more like a keyword test almost, right, than pure script. And again, that's the power of object-oriented programming, right? I'm building code that's easier to follow. You add the BDD statements in, like I said earlier, and you're adding even more structure to this and something that's, again, going to allow a greater audience to not only understand and view this, but to perhaps assemble their own test cases, right? Reuse these code pieces, these BDD statements that have been implemented, and then launch them as well, as we'll do next, right? To kind of end, as I'm launching this, maybe I'll give the mic to Prashant Nakshita to make some comments, but just kind of finish here. Again, this tool fitting in a nice agile development process. I can run this standalone here in my IDE. I could run it from a command line process, and then from there, plug my code into using a CI/CD tool like Jenkins or TFS to launch my code. I could launch it from a test management system like our QA Complete, for example. I could do a lot of things like that, right? So BDD obviously is a nice way to run this code from a testing perspective, from that strategy perspective, but really think of it like this. This is code. You can implement it in whatever manner best suits you. You don't have to use BDD. We're simply certainly angling for it because we feel that it fits this story very well. But let me give you guys the floor while I run this application test for us. All right. Hoping that me adding this class, there it is. All right. And what we'll do is I'm going to run it locally in my folder here. So we're just going to build directly in the IDE. I'm using right now JUnit and Maven to compile everything. Definitely recommend using Maven. It makes it really easy for you to get all the dependencies into one nice POM XML file, which then is really easy to kind of launch that via command line. Reduce the number of files you have to include in a command line argument, right? It also allows you to again, take advantage of using a lot of different resources, and it's free. So who doesn't like that? But you could also, TestLeft actually comes with other unit frameworks you can use. You can write an MS test, NUnit, XUnit. You can incorporate it into a JUnit TestNG framework as well. But certainly recommend use of frameworks as well. It adds, again, more structure that's reusable for you, the testers. Right? And then as you can see, just like any good automation tool, it's running through my 3 tests. I actually had 3 Gherkin files, and I didn't say this earlier, one that added an order, one that deleted all the orders, and one that deleted one order. But again, the beauty of this process is that all my feature files are sharing this one web order steps.java implementation file, right? So then if I have certain Gherkin statements that I know are implemented in one file, I can maybe rewrite them in a different order, use them in different scenarios, and have my Gherkin files plug into the implementation. And another way, which we can see reuse, saving our development test team's time. But that's my spiel.
All right, great. So you mentioned a couple benefits. So I just want to kind of reinforce those benefits that we didn't talk about earlier, which I think is really powerful when you combine BDD and TestLeft together. So you showed us those 2 test creations, the speed, which I really love. So you can automatically generate your application models and pages in 2 clicks. which is, saves you so much time with regards to test creation, but also test maintenance. The second is that readability and collaboration. So by creating these requirements in BDD, you also can have anyone understand it. It's in this given when then format that is completely readable by a business analyst, completely readable by a developer and a tester. It can really break it down into that basic business terminology. And that last portion that you were talking about was that reusability. So by building your feature stories in BDD frameworks, you can create these modular test cases to be reused over and over again. And that kind of reinforces my three favorite things in TestLeft. So I wanted to kind of share a specific slide with you around my three favorite things, which is just like that 2 clicks aspect of it. Makes it super easy. You can start maintaining your properties and methods and classes all in one single file. The BDD apps aspect is something that I find super compelling as well, because we support all the BDD frameworks in addition to kind of reinforcing this agile development that people really want to accomplish. And then because it is in your IDE, you are getting all the benefits from all of the other systems and DevOps ecosystems that you have already plugged into your IDE. So you don't have to go through these additional steps that you may have to with other kind of tools out there. You can easily leverage your DevOps ecosystems that's in your IDE to continuously integrate into your continuous integration and delivery process. All right, so that leaves us with 5 minutes to answer any questions. I think we've addressed a lot of questions. We've got a lot of traction over the Q&A and the chat room. So hopefully we addressed many of those questions, but feel free to add any more and we can answer them live as well. Seems like we have a couple that we didn't get to. So somebody asked if this was an automation tool. So yes, definitely is a UI automation tool that seamlessly embeds in your IDE. So there's another question.
So by R. Rajesh, could you tell me which way shift left testing is more significant to find defects earlier? I think, that graph that Akshita showed earlier was definitely a good high-level story of that. But the idea is that if the whole idea of shifting left is just to move this iterative process, right, of reviewing your code, fixing your code, looking for faults earlier in the cycle versus later. It's not only from a bureaucratic sense, right? It takes more time if you're finding code later in the cycle to send that back to development, have them fix it, then send it to your siloed QA team for them to work on. The idea is that let's move away from that more archaic, more lengthy type of sequential workflow. Let's iterate on our product more consistently, right? So if you're having your developers find bugs, for example, they're going to be more intimately familiar with the source code than perhaps any tester, right? Unless they're working on directly in the same team. It's going to be quicker for them to find a bug, right? Given they've written the code themselves, than it would be for someone investigating code you've written. It's kind of like if you wrote an essay, someone who would proofread it might see some faults you didn't see, but you will know the structural weakness is far greater, right, than anyone reading it from scratch, right? So that's part of the idea there. And then the other part is if you're constantly iterating and being more agile in how you find your bugs, right? And especially from the design phase, Prashant Akshita said, you're taking into account what the user will deal with earlier. You're scripting out those corner cases, those base cases more cleanly earlier. You're going to have less bugs to deal with in general. For the, that you've seen that trend as well. And so the idea of being agile is not only fix bugs literally quicker in time, but then also reduce the amount of bugs you have in general as well.
I think there were a couple of questions about what programming language can be used. So Java, C#, and VB.NET are the 3 languages that you can use TestLeft with. And we believe that this, most of the applications are built on C# and Java, and so integrating your test code along with your application code is why this is very beneficial.
Somebody also asked about what's the difference between leveraging an open source tool and a tool like TestLeft. So that's really the really big benefit is the first one you see on the screen. We have this great object UI spy that allows you to essentially maintain all of your properties, methods, and classes in one single file, but it creates that application model, or for a website, an application page model, and generating that in the 2 clicks. Whereas with an open source tool, you would have to manually program those descriptions, manually program those objects, which would lead to many more lines of codes that you would actually have to maintain. So the biggest advantages are really the test time in test creation and in test maintenance.
Yeah, and this is something that might not be intuitive as you're watching this demo. So we highly recommend you go to the TestLeft website. You have a look at some of the information there. Download the trial version. There's plenty of samples for you to get started. There's a great documentation material, and everything that you need, some videos and everything else that you need to get started easily. So I think that's something that you should try out, and we would love to hear back and what you think of the tool as well.
So unfortunately, we are out of time now, and we know that there is a number of questions that we didn't get to answer, but we'll go ahead and follow up with you afterwards to address those pending questions. Thank you so much for joining our webinar. And the recording, as a reminder, the recording will be made available on demand at smartbear.com/resources/webinars. So feel free to go back and check out the webinar if you want to go ahead and share it with others as well. Thank you so much and have a great day.